Hello everyone, we are going to begin by adding 3/5 plus 2/7. And of course these were chosen intentionally because the denominator 5 and the denominator 7 are not the same, which is really important when we're adding fractions. We are going to use a process of writing equivalent fractions. So begin by writing 3/5 and I'm going to multiply the numerator and the denominator by 1, which gives me 3 times 1 is 3 and 5 times 1 is 5. So this is not necessarily an equivalent fraction, but it does help illustrate the process. This time we're going to multiply the numerator and denominator by 2. 3 times 2 is 6, 5 times 2 is 10. Now we're going to do the same fraction, 3 over 5, but this time multiply the numerator and denominator by 3. This will give us 3 times 3 is 9 and 5 times 3 is 15. So take a moment right now to note that 3/5 and 6/10 and 9/15 are equivalent. They represent the same amount of whatever it is that you're talking about. Now let's do the same for the other fraction, 2/7. And remember, we're going to start by multiplying the numerator and denominator by 1, which does not give us an equivalent fraction. It is just used for the purposes of helping illustrate or illuminate the process here. But now we're going to do 2 over 7, where we multiply everything by 2. And we get 2 times 2 is 4, and 7 times 2 is 14. And now we're going to do the same fraction, and this time multiply the numerator and denominators by 3. And we get 2 times 3 is 6, and 7 times 3 is 21. Now we're going to expand this a little bit so we can see all of our new equivalent fractions. And you'll notice that there are no denominators that are exactly the same on the list on the left compared to the list on the right. We have a denominator of 5, 10, 15, and on the right we have 7, 14, and 21. And this will happen often. And what we're going to do from this point until we find a denominator that's the same, we are going to continue expanding our lists. This time we're going to go 3/5, where we multiply the numerator and denominator by 4, and we get 12/20. Now 20 and 21 are very similar, but in math that is not enough. We're going to continue expanding the list, this time multiplying the numerator and denominator by 5, and we're going to get 15/25. Now I am making that list longer, so we're going to take a break for a moment and expand the other one just a little bit. Multiply everything by 4, and we get 2 times 4 is 8, and 7 times 4 is 28. Still no denominator that's the same, so we're going to go ahead and continue expanding this one. This time we're going to multiply everything by 6. 18 over 30. 18/30. And again, with the 2/7, this time multiply everything by 5, and we will get 10 over 35. Still no denominator that's the same on each of the sides of the list. So now let's go ahead and expand this one by multiplying everything times 7, and we get 21 over 35. And there it is, ladies and gentlemen. We now have a fraction with a denominator of 35 and another fraction with a denominator of 35. These are the two equivalent fractions that we are going to use to solve our original problem. So our original problem was expressed as 3/5 plus 2/7. And when the denominators were different, of course, we could not add them. We had to write equivalent fractions and discovered that 3/5 can be rewritten as 21/35 and 2/7 can be rewritten as 10/35. And because we did all this work to try to identify a denominator that's the same, please remember to keep it the same in your answer as well. The only thing that you have to actually calculate is the numerators, 21 plus 10, which is 31. There is the final answer, 31/35. And then, of course, because we did all of this work, we just as well could have subtracted these two fractions. After doing all that work, we ended up with 21/35 minus 10/35, if that was the question that was being asked. We still end up with 35 as a denominator. The numerator would have been 21 minus 10, which is 11. An awful lot of work. Sometimes you will have to write quite a few equivalent fractions before you find the ones that share a common denominator. It is a lengthy process. It can be a lengthy process, but you end up using quite a few math skills that are very, very good. Thank you so much for your time.